A very good morning to you all. First, let me apologize for the delay in our starting. We welcome you to the third and final day of our annual JIE Engineers Week 2020 conference, which is being held under the theme, Reaffirming Engineers' Importance to Jamaica's Development. I am Glaister Ricketts, the moderator for today. For those just joining us today for the first time, the annual JIE Engineers Week is the premier event for engineers across the Caribbean and the region interested in professional growth and innovation. So far, we have had presentations from academia and industry covering topics such as growing and sustaining manufacturing during and after COVID-19, the fourth industrial revolution, a model of accelerated economic growth, improving Jamaica's productivity and engineering's perspective, 5G and COVID-19, truth or myth, combating COVID-19 with big data and artificial intelligence, Port Royal Sea, the Port Royal Sea Walk, the cruise gateway to Port Royal and the Greater Kingston area, development of a new town, the Bernard Lodge development, and coastal protection of the Kingston Harbor. Today's theme is maintenance, engineering, and management. Our presenters are Engineer Godfrey Boyd. He is the General Manager of the Petroleum Company of Jamaica, PETCOM, and he will be speaking on maintenance engineering in the healthcare facilities. Engineer Kelicia Ebanks, Manager of Engineered Solution at Dendock and Company Limited. She will be speaking on air quality and ventilation in buildings, implementation and maintenance. Engineer Rupert James, Facility Manager at the Port Authority of Jamaica, and he will be speaking on preventative and reliability engineering. And finally, Mr. Andrew Dale, Assistant Director of the Occupational Safety and Health Department in the Ministry of Labor and Social Security. He will be presenting on health and safety in the workplace. Our first presenter today is Engineer Godfrey Boyd. A professional engineer and an executive management professional with over 30 years in strategic planning, operations, and maintenance engineering in the energy and health sectors and the petroleum industries. He worked at Southeast Regional Health Authority for over 12 years and held positions such as Director of Operations and Maintenance for the Kingston and St. Andrew, St. Thomas, and St. Catherine area. He has been Parish Manager for Kingston and St. Andrew Health Services, and also CEO of Kingston Public and Victoria Jubilee Hospital. He is a part-time lecturer in maintenance engineering and management at UTEC and is the current General Manager at the Petroleum Company of Jamaica, PETCOM. Mr. Engineer Boyd is more than qualified to speak on the topic of healthcare. To speak on the topic of maintenance engineering in the healthcare facilities. At this time, I take pleasure in hand over to Engineering Boyd to make his presentation. Please help me welcome Engineering Boyd.
Hi, good morning one and all, and I welcome you to the JIE 2020 Engineers Week. So this morning I just want to engage you all in some discussions having to do with maintenance, engineering, and management within the healthcare sector. And as I walk through the presentation with you, I hope that it will be informative and that it is one that will enlighten those of us who are engineers of the need for engineering within the health sector. A little historical perspective. Back then, 30 years or more, in the 60s and 70s, there was a development or an expansion of the healthcare facilities. It was thought that they needed to modernize to suit the growing population. And so several health facilities were developed or were constructed. And I use the word constructed very carefully. They were constructed, and we had things like new operating theaters, new biomedical and diagnostic equipment were purchased and installed. The ironic thing at that time is that all of this expansion or construction was unaccompanied by a similar setup for maintenance program and maintenance personnel. So at that junction in time, there is no continuing educational programs that would basically prepare the staff to operate or maintain and repair these facilities. So if we look here in Jamaica, most things were centralized. So you had the Ministry of Health that basically took care of all the institutions that were based across the island. And as a result of which the service providers moved out from Kingston outwards to serve. And of course, it means that there would be problems in relation to time of response, in relation to transportation, and just basically getting the resources to the points where they're needed. The universities, and it still is today, it's a little better now, were not equipped, neither themselves nor the technical schools, with providing the education and training that was necessary to develop the persons who worked in healthcare. And as a result of which, the staff members who worked in healthcare were not afforded the opportunity unless they went overseas to be trained. And so the scarce resources meant that the timeliness of response would be a problem. And what we found then is that the biomedical equipment maintenance, especially looking at the sensitive pieces of equipment, was the least developed areas in the. If you looked then and now, 1986, a study was done by PAHO, and it showed that there was a shortage of managers and technical staff for engineering and maintenance programs. Checks to date will show that that shortage is still there, primarily because we are not getting the throughput from the universities. 75% of the persons who are working in maintenance had very low levels of schooling. Most persons are from the primary or secondary area. They got a job in the government services and they started learning. A lot of the training then was what we call hands-on training. And our engineers, you might be familiar, are persons in the technical field, what we call rub-off training. So you know, if I'm trained the wrong way, or I was taught something the wrong way, I would spend years perfecting it, and I pass that knowledge on to someone else, and they perfect the wrong things, and we end up doing the wrong things. So 19% also of the persons who are trained in technical school, they were trained as basic technicians. So persons may have gone to a JAGAS or they've gone to a technical school, but they were not biomedical trained persons, right? So if you look at our hospital settings, what you'll find is that everybody says, oh, I remember doing a presentation back in the 2000, and I think in 2006, 2007. And when I made a presentation, actually it was to a group of engineers. And when the topic was introduced about engineering in healthcare, someone asked, but health is only about doctors and nurses and pharmacists and those that are allied to medicine. And I had to laugh because the thing is, whose equipment are they using? Who builds these equipment? Who maintains the equipment? The facilities that are being constructed, who constructs them? Right? The processes that you're using, who is doing those? And then was a little bit of an eye-opener for most persons, because you're now seeing the need for engineers. And I have said engineers, but also specialist engineers with it. Now, one of the reasons why the attraction is not there for healthcare is because of low salaries. In the government services, you know, the wage scales are set by the Ministry of Labor. Those, if you're allied to medicine, you tend to get more paid than those persons who are classified under the administrative banner for which you're engineering and other services. That's how the scales are weighted. So unfortunately, with low salaries and the truth be told, limited possibilities unless the engineers further themselves in other areas, such as doing a master's in finance or an MBA, etc. They would be basically stuck at the level of just being a technical operative until they would have departed the service area. So the common issues in general, and it still surrounds the hospitals and the healthcare facilities today, is one, a lack of the maintenance engineering. And I want to get it clear, I'm talking maintenance engineering, because the common thought process is maintenance is done by a grease man, or what we call an artisan. And the thought process is somebody with a piece of cloth, wiping down machinery, sweeping up the place, someone who is basically just a fix-it man. So lack of financing, lack of transportation, inadequate supervision, because then you didn't have persons who were properly trained, and lack of adequate tools to do the necessary job. So it presented a number of challenges. One is low institutional maintenance quality. Now, I give an example. I've asked a question before in another forum. Who is a plumber? And the answer that is often given is somebody who fixes the pipe, and if the bathroom wants to be fixed, that person fixes the bathroom. But the thought process that we want to get to is the fact that it is the availability of water, the proper disposal of waste products. So if, for instance, a nurse who is at a hand washing station is to have water, and especially now we're talking about the COVID-19, then the plumber's job should be the availability every morning, every day, every time that the water is available. That every time the bathrooms are flushed, we have adequate disposal of the gray matter, or wastewater, gray water, as some people may call it. High levels of things that are obsolete. Why? Because back then, Jamaica is a country where everybody wants to donate. And unfortunately, some of the donations are not necessarily new. Some have reached the end stages in the areas that they were being used, and unfortunately, they then become donated to us. And therefore, it means they came without spare parts, they came without manuals, and of course, the staff here are not trained to deal with them. So you have equipment that as soon as it comes in within a year or so, you have had to dispose of them. Bad quality perception. Now, if I'm a nurse and every time I'm at a hand washing station, there's no water, then my perception of the maintenance department or maintenance engineering department is that they're not doing the job. They're probably lazy, or they don't know what they're doing. So for the end user, it is getting their services all the time, having quality services delivered on time when they need it. The lack of financing is always a challenge, because the healthcare facilities, those in the public institutions, they get their monies from the ministry. And therefore, the ministry also has other priorities in other areas, education, income, energy, infrastructure for communities, etc. So it's not that we are awash with monies. So there are the challenges with finance. Right? So I share this wishbone or this fishbone chart with you, just to show you some of the things that are affecting why it is that increasingly there's what we call corrective maintenance work orders. In other words, there are problems and that need to be addressed. Equipment and buildings, we spoke a little bit about obsolescence, poor specifications, because invariably the persons who are buying the piece of equipment is not necessarily the engineer or the engineering or technical person. We have had situations where the pieces of equipment were being bought, and I relate one to you, where a piece of equipment was bought by a doctor. And I remember that person calling me to say, Mr. Boyd, the X-ray machine is on the wharf. When you guys gonna put it in place and start using it? And I'm like, what X-ray machine? Suffice to say, it was a brand that we did not have here in Jamaica. And suffice to say, the preparation of the place to put it in took us almost 2 weeks or more to retrofit the place, just to fit the equipment. And of course, there was no training, there was no manuals, etc. So these things do happen. Diversity of brands. If you're not having commonality of equipment, it's a problem for maintenance, because one, with training, two, with spare parts, three, the user. Each different brands have their different techniques or their different modalities of how they work. And it's important, because persons now often go by rote. They come, they turn on this machine, they see particular lights coming up, things that would indicate that the machine is available and ready to be used. When it's a different brand, sometimes it gives them a problem. And therefore, it's important that we look also at the commonality. On the maintenance staff, I said it again, I've said it before, lack of training, education, and sometimes also some poor attitude, poor work attitudes. Salaries are an issue. For the hospital staff, attitude, knowledge, ownership. Now, this is a very important aspect. As engineers and technical persons, once you're talking about maintenance management, it's important that the operators own the piece of equipment, right? Because if they don't feel like they're owning the piece of equipment, what will happen? They won't take care of it. And sometimes even if the machine or the system is giving off warning signals, it is ignored, because as far as they are concerned, right, that's not my business. It's someone else's job to pay attention to that. So it is important. The response time, if there is a problem, and especially as you do critical, when you do risk management or you do risk analysis on health services. For instance, if you're talking about an operating theater, and we're talking operating theater lights, I want you to visualize with me, you are having surgery done, you're on the table, and you are put to sleep, you're under general anesthesia. And it may have been that your chest is open and your heart is out on the table, right? Or your skull is open and it's brain surgery. So you can imagine the team around you, and then the light goes. Now, it means response time is gonna be critical. The time that the backup generator comes on, right? Or the other systems that will enable them to continue the surgery. It's gonna be critical. So you don't have 2 days or 3 days to consider what you're gonna do, right? So response time is one of the things that was affecting, and especially if you're central. For instance, if all the resources are in Kingston and you're to respond all the way in Montego Bay, you're gonna have a problem, right? Just some general information, because I want you to understand the gamut, how detailed, how massive the responsibility is. We have over 23 hospitals of different grades, A, B, C, specialist hospitals, etc. Over 323 health centers, and these health centers serve the community. So they are in the communities, they're in the towns, in the parishes. So it's not like they're centralized in one area. So it means journeying to them, it's gonna take time. And especially if you're coming out of Kingston, for instance, and most of you would have encountered the traffic that takes place during peak hours. We have buildings, right? Operating theaters. We have over 40,000 pieces of equipment. Then we have over 20,000 pieces of biomedical equipment. Now, who services those? Last approximate check, give or take, about 20 engineers, 40 persons who are directly charged with technical supervision, about 179 what we call artisans. And then if you look at the real operational here, you have no more than about 7 engineers at that level, right? Give or take their boss. So you could say 6, but let's use 7. And then we use external contractors. Okay. So it's great. Good business. Somebody else outside can help you. The question is, are those institutions trained? Are those companies, are their staff trained? And will they respond accordingly? All right? Some areas, just to show, again, to show detail, if we look at the medical services, all of these areas, from general surgery down to plastic surgery, cardiothoracic, cardiology, if you look at hematology, even dietetics, we have kitchens, we have nurseries that we must provide food to the patients. So it means that we have stoves, we have boilers, we have sterilizers, we have other things that are there that needs to be maintained. Yeah. On the diagnostic side, we're talking about our things used in radiology, we're talking echocardiogram, ultrasound. A woman who goes into a hospital for a woman issue would like to know that the CT is working, would like to be able to know that the ultrasound is working, right? Especially if she goes to a gynecologist, you would like to know that the equipment is working. And anyone who have over the years have listened to the news, pediatrics, especially Victoria Jubilee Hospital, Bustamante Hospital, it is so critical that the systems are working, right? So this is just a listing for you, just to show you the pieces of equipment. See how wide it is, right? From beds, whether be it mechanical beds or electrical beds, looking at orthopedic drills, MRIs, X-ray units, anesthesia machines, patient monitors. This is just showing the gamut of things that engineers and technical persons have to manage on a daily basis. All right, and the services, I paused so you could see them, looking from your generation all the way down to your dental systems. I'm hoping that you're getting the sense or the import of engineering, all right, in the healthcare. So it's not just somebody who is sweeping up the yard. It's not just somebody who comes in and because the roof or the ceiling tiles want to change, that's why the person's there, or a light bulb needs to be changed. But serious engineering takes place in healthcare, and there's the need for further involvement of engineering and technical persons. Just some of the roles: clinical and biomedical engineers and other engineers, civil, mechanical, electrical, industrial instrumentation, chemical computing, etc. The list, as we diversify the categories, is very wide, right? The biomedical equipment technicians, those that will directly now work on the pieces of equipment that I have shown you above. And we do have medical technologists. So most persons will be familiar with those persons, especially if you go to a lab, right? So for if you're testing your blood also, you have a medical technologists who are there, who manages those pieces of equipment. And then we have the maintenance technicians. All right. I will skip a little bit through these slides, just talking about Generally, what clinical engineering is, you may have heard me mention clinical engineering. Clinical engineering basically is the management of engineering and management skills to help technology and systems just to make sure that we can support and advance patient care. And so therefore, clinical engineering is it's very wide. The biomedical engineers tend to be the specialists in the area because the concentration is more on the equipment rather than the total processes and the facilities and the systems. All right. So I will, if you just forgive me a second. But impact, basically. So medical requirements, human engineering. It's interesting because we think of medical doctors and nurses as being the one that touch the patients. But engineers have to know about the body and know how they function to know how to fix or how to gauge the machines that they are being used or the equipment being used to make sure they have the right responses, right? Safety, the design, utilization, what type of utilities is necessary, how we're going to maintain it. Cost and economics, we're not awash with funds, and therefore, we have to look at that aspect of maintenance. Are we wasting money? Are we buying a piece of equipment that is in terms of reliability? And I think a presenter later on will be speaking about reliability in maintenance management. But will that piece of equipment break down? We have had systems in this country where, yes, we have bought contracts for service, but the service providers are overseas. And therefore, when it breaks down, it's going to take them a while to respond. And you usually have to put them up in a hotel, and then you have to pick them up and carry them around. And so sometimes just to have the machine fixed takes you almost a month. Right? So your engineering is looking at all of these. What are the safety and accepted medical practices? And then how we plan for the future. So to ask a question, maintenance in engineering. What is maintenance? What type of maintenance we're talking about? I've showed you some of the things and the systems that is used in healthcare earlier. Why is it important? What's the cost of it? What does maintenance cost the organization? The idea I want you to leave you with is this: transforming on the mindset, being proactive rather than reactive. Seeing, that's what engineering is about. Engineering is not just about fixing the problem as it occurs. It is about forecasting. It's about projecting. It's predicting that something can happen and therefore put the systems in place. There's a saying of, and I like to use, it's called a dirty house syndrome. You know, if you look at somebody's home and the outside is dirty, the yard or the whatever you call it, the garden and everything is very dirty, there's trash there. It's very hard for you to tell somebody that inside of the house will be nice and clean. It's very hard. And this is where maintenance engineers have to wrap their mind around that. Listen, it starts with the small things. It starts with the small things. If the outside of the building is not being maintained, it means that something's going to happen to the inside. If the piece of equipment on the first tier level of maintenance, that means the cleaning, the oiling, the checking to make sure that all the lights on the systems are working, that the plug itself is able to be connected into a socket so that electricity can flow. If those things are not attended to, then it is saying that we are short. I once walked into a hospital, Bustamante Hospital, I can name it for a fact. And I was passing and I heard water. But because it was so audible, in my mind, it must mean that a lot of water was running. So I opened the door to a pantry and I saw the pipe and the water was running at full force. So being the engineer, I tried to lock it off, realized I couldn't. I bend down, look underneath, try to use the lock off. The lock off was rusted away and I couldn't turn it. So I came back out and asked a question of the sister who was in charge of the ward. How long has this been happening? And she says, sir, I'm glad you're coming. This has been happening now. This water has been running. I kid you not. over the last 3 months. And I had to ask her again, and she said, yes, other nurses confirmed it. And I said, but this is madness. Now, all it needed, because I remember buying that faucet for somewhere else privately, and the faucet then cost me about $2,500. So for the want of $2,500, and for the want, even if we're going to buy a lockout valve, if it even costs us $3,000. So for the want of $6,000, we allow water to run for 3 months or more. And then we say we don't have monies. So it is looking at that mindset that says, listen, if the small things are happening, then bigger things are happening, right? So the object of anything in maintenance is to look at, one, how well we can do the program, that we can manage the equipment properly. How can we develop our resources, the human resources, right? How well can we develop the technology, put in the applicable technology, the tools, looking at the computerized maintenance system. So it is a transformation of our mindset. Rather than being a cost center, that we are always demanding money, can we become a profit center? Meaning we are looking at outcomes. So when we're doing things, we may not be an institution that is selling products and therefore getting revenues in, but we are selling services, and the outcomes, the positive outcomes, is revenue for us. So it is transforming the mind to become more of a profit center and transforming our organization rather than just reacting or being a cost environment where we're just taking, and taking. So it's always the thought process. Is it their monies or ours? We engineers, we are Jamaicans, we're paying taxes. It's our money. It's our money. So it's not sufficient for us to look the other way. It's not sufficient for us to say, well, it's somebody else's problem. The government must fix it. My challenge to the engineers here and the technical persons is that we need to get involved, because it's our taxpayers' money. It's our loved ones that are being served. It's our loved ones that are being affected by the quality or the poor quality or the lack thereof, right? So it's important. So, you know, there's a saying that maintenance is, I heard it the first time I heard it umpteen years ago. It says, keep it like it is plus or minus depreciation, right? And basically it is saying all activities required to keep the facility or equipment in a particular condition or to return it to that condition, right? So we're talking about preventative, predictive, we're talking about restoration, right? But it's always about using quality inputs, quality data, quality processes to quality train and energize staff, and those staff being the owners of it. So always the objective of maintenance, I'm sure you'll hear a little bit more about that from some of the other presenters, is you want to make sure that the systems are always available, right? And at the lowest cost, maintain it at the lowest cost. And above all things, safety is number one. If you're talking healthcare, the patient safety is number one. I give an example. If you're using, for instance, an electrosurgical unit, something that assists in surgery to seal and heal cuts and stuff. So you can imagine if you're doing that and it's off spec in relation to the voltage or the current, whichever you want to use, and that patient gets burnt. You can imagine an X-ray unit that is off spec. And so instead of radiating, for instance, your spleen, you're irradiating the liver or the heart or the kidneys, right? Within safety prescription, very, very important, right? So maintenance must always be included. Well, we're doing projects, we're doing research and development, manufacturing, we're utilization and operations. Design is important. It's important for us as engineers to learn to design out the maintenance. Most importantly, because if you can design out the maintenance, that is, you're selecting the right designs that is applicable for the time and also can serve you for the future. If you're selecting the right pieces of equipment through the right specification, you're getting the parts, the training and stuff, make those designs functional, then what you have happen is that it is best for all. I give an example. If you were to look at just a building, most of the buildings in healthcare, I would tell you, were not built by civil engineers or others who are trained and certified in engineering, healthcare engineering. A lot of the buildings are built, they're built very nice, but they're built some like office buildings, some built like houses. Now, let's look at the corridor, for instance. Think of a health center if you have been to one, or the hospital. If you're passing down a corridor with a patient on a stretcher, or you're pushing a trolley and there's an emergency, it should be such that you can what we call wheel a stretcher around and go in the opposite direction. In a lot of these places, you can't. You have to back into a room and then come back out. Even if it's sometimes even with a patient who's on a wheelchair. So as you're designing, we have to think of some of those safety factors that are there, right? So it's important to think as you talk about maintenance. Correct and timely maintenance helps us in reducing the downtime of the equipment and the facilities, right? A reduction in the replacement costs versus outages that are going to happen or the unavailability of the piece of equipment, right? As I said, when we're talking revenues in healthcare, we're talking about patient outcome, positive patient outcome. So if you have increased availability of your equipment, your X-ray systems, your ultrasounds, your MRIs, your CTs, then we have increase in outcomes, right? So it is important, right? It's important. We need to improve, and we have cost savings, right? The proper and appropriate selection of equipment and facilities. This is so important. This is what engineering and technical persons must know. Because if it is that you're talking about, and let's use COVID-19 as for example, we have had a rush in a lot of the facilities now to put in hand washing stations and to put in sanitizing stations, etc. We are now, as an institution, the JIE and others have been making presentations, and the discussions have been about air conditioning systems. Now, an air conditioning system for an office in a business environment is different from air conditioning systems that is sitting in a hospital or a healthcare facility, because you will have various airborne diseases that can happen. It's not just COVID-19. We had persons who come in long before were coughing and sneezing and passing on germs to others. Now, if the air conditioning system, and most places you check them, they have split units. A split unit does not breathe. To the best of my knowledge, I stand to be corrected, but it doesn't breathe. What it does is circulate the same air in the building, but makes it cool. So if I have a number of persons there with something that is airborne, the truth be told, I question if I really want to stay in that building. So I was saying the proper selection, the proper and off, and what is appropriate is most important thing. If you have an operating theater, the operating theater should have a fresh air system, at least 15 passes of fresh air per minute with positive pressure, keeping out anything, make sure that nothing comes in the room, right? Some of you, if you have been into an operating theater, and I only hope it's just for observation and not to be worked on, but you'll realize that when you're trying to push the door is pushing back on you because of the pressure that is inside. So it's important to understand. Many years ago, we were into breakdown, where we just run the things down, it breaks down, and then we respond. That's not where we are today. That's not what we want. That's not what we want. We want to be able to predict. We want to be able to say, okay, we are going to implement a maintenance programs that will extend the life of the piece of equipment or the processes, and that will make it quite safe, right? So again, I said, can failure be designed out? Can the life of the parts or the equipment be extended? Can we put in condition based? You know, when you're lying in a hospital and you have all of these machines, everything is watching your vital signs. If your heart stops beating, there is a monitor that will start to beep. That's condition monitoring. I'm monitoring your heart, right? It's the same thing. Are we monitoring the conditions? Do you know how many institutions, and if you check the places where you work, ask yourself a question. When last have you had a thermal scan done of your electrical circuitry and the panels that you have? When last have you checked? If you have, for some places, when you do that thermal scan, you will see that you have a lot of hot joints. You will see that you have corrosion. You'll see other problems. When last have we monitored, right? So these are just some of the maintenance procedures: operate breakdown, put it on a fixed time program, so every 2 months or every 3 months. Monitor the condition, right? Monitor if you are doing something, for instance, if you're doing hemodialysis and you have the water systems, you may have to monitor the filters. You know how long the life of a filter is, and therefore you have to change those filters as you go. I spoke about designing out maintenance, and of course, life extension. You know, like just a common thing for you. You know, you have your car and you take it, you put it in the garage and you go through everything, all the oil, the seals, everything else. You fix it up and it's okay. You do the dew coin, everything, change the shocks, and you're ready to go. So you have extended the life of that piece of equipment, all right? So let's just talking a little bit about the corrective maintenance, that is either planned or unplanned. You want to make sure you have planned maintenance always. It's more, you can control it. When it's not planned, you're gonna have a problem, right? So as we talk about PM, preventative maintenance is important. Yes, most persons know of a fixed time. So for instance, your car, somebody will tell you that, okay, every 3 months or every 6,000 kilometers, whichever comes first. And most times they'll tell you, even when you're not driving the car, they'll tell you, oh, 3 months have passed, you need to service it and pay a lot of money. But if you check it, the quality of your oil is still great, right? Similarly, that's why sometimes you move to the indirect method, which is condition-based. I monitor the condition. If I'm using the piece of equipment more often than not, and especially mission-critical areas, I might want to do the maintenance earlier than what it would be on a fixed time, all right? So basically what I was saying is that if you're looking at a maintenance system, this is just showing you some of the inputs that are there. Getting information, knowing what the requirements of the work is, work order, looking at preparation, the planning, the setting of the priorities. Do you have instruction sets? Do you have drawings, documentation, the as-built drawing? Do you know how many institutions, when the engineers or the technicians go to do the work, they can't find the drawings, they can't find how it was built? The concept is there, but how it was built, it's not in existence. How to troubleshoot. Do we have the spare parts and material? Who is making the purchases? In most cases, what happens is the purchases are being dominated by those in the accounting area. So they are just making decisions, not the technical persons, but who is using it, who is fixing it, who is responsible for maintaining, who is responsible for it if it goes bad, technical persons, and doing the inspections, right? But that is most important. So we're talking about the ability to eliminate and reduce failures, to eliminate and reduce the need for maintenance, to prevent wear and destruction or breakdown, all right? So this is just talking about a little bit of the advantages of doing preventative maintenance, right? But basically it is talking about better use of resources, better quality of work, planning of your work, and the need for readiness. All right. I'm skipping a little bit through the slides. I will, because there's something I want to come to where I want us to understand. If you're talking about maintenance of systems, it's important for us to understand that the response to the customer is very important, but more so, who you send to respond to the customer is most important. Most important. They many times over, and I will just, forgive me, I'm going to a slide where I want to talk a little bit about the customer service. As you see here, I've given you what I consider a service circle. Stores, your plant managers, your marketing and your salespeople, your community, your shareholders, your operation, your administration, your accounts, your finance, and all of the stakeholders. All of these persons are basically in your circle so that you can serve the customer. Because the customer is key. Now, the aspect of it is that every customer wants a desired results. And that is what the patients want when they come into the hospital, right? That is what they want. Now, there's the adage of, well, I'm the doctor, I'm the nurse, I dictate. Or I'm the engineer, I can dictate. Maintenance versus operations, who wins? None of us wins. It is supposed to be a win for the patient. And therefore, the application of our customer service and the follow-up technical works is most important. So I speak about what I call it the transforming the mindset, which is a Chinese shop approach. You ever notice that you have a big supermarket and it opens for a particular time and it closes at a particular time, but you can go around, for especially those here as old as me, there's always a little Chinese shop that will sell you a quarter bread, a big jar of oil. They'll sell you things, and now we have other persons who are doing it. But the fact is that they are available because they know when a patient comes home, that patient is not going to be set in a particular time. So Bustamante Hospital, for instance, realizes that their patient flow after 6 o'clock increases. Why? Because that's when mommy and daddy gets home. That's when they realize that the child is ill. And that's when a lot of times they rush to get service. So it is looking now, how do we set up shop to make sure that whilst we do our maintenance, we are serving the customer, right? And first tier is the person who calls. So your customer service, your maintenance, part of your maintenance requires, who's your customer? It must be around the need of the customer. So if a nurse, I started off with a hand washing station. If a nurse is not getting water so she can sanitize to attend to a patient, and she consistently and constantly have to complain, that's poor customer service. Now, you know what happens? Oftentimes, so we say, okay, we send the artisan down to go and check. The artisan goes, he may not have spoken with the right nurse or the nurse who is making the complaint. So he or she has not found out what the real thing is. But of course, what we do in health is that we make up a list of equipment. Who is making up a list of tools and parts needed? The person who has gone, who has not done a good assessment. And I'll tell you what I have found in my limited time is that a lot of times over, because there's no consultation or proper consultation, what parts and services that are required is not what is applied. And sometimes, unfortunately, those parts and services find themselves elsewhere. I won't get into that aspect. But it is important for us to understand that. As engineers, we need to keep data. I believe a good engineer always uses data to do analysis. That's what's going to help you with your prediction. So do you have the form? Do you have the inspection sheets that will be used? So when your person goes They can capture adequately the complaint. You can log those complaints and then make analysis. Which is it? How are we viewed by the persons we serve in the hospital system, and by extension, the areas that you are in? Are you a greaseman? Do they see as a mechanic? Because you know all mechanical engineers are referred to as a mechanic. If you're an electrical engineer, or electrician, a computing engineer, you're just a computer technician, etc., etc. Right? How are you viewed? Right? What about your department? What about the delivery? You know, most engineering or most maintenance engineering departments is at the back of the compound. Check it out. We're normally near to the garbage bin. That's where we are. That's how we are viewed. And that, unfortunately, is also how the institution sees us. And therefore, when you start to argue about monies, you can't. I've learned in my short stint in industries is that engineers and technical persons need to know to speak finance. Engineers, if we're talking medical outcomes, patient dying, an engineer or maintenance person need to know how to speak to getting what they want or how it will affect negative outcomes. To be able to express themselves in that way so that we know what we can get, right? Are we profit center or cost center? It's important for us to understand. As we talk about reliability, what are we using? Are we just fixing and then tomorrow we'll be back? Or are we gonna fix so that I don't have to hear the complaint of the nurses? I want to leave you with an experience that I had. I went into a newly constructed facility on one of the hospitals. I won't name it. But the first thing I noticed is that when it opened, it wasn't open, and when I inquired why, I heard all manner of other reasons. But basically, there was a 9-point defects list that was handed over by the contractor. When we opened the door, it was a 2-story housing complex. When we opened the door, we saw dirt in every, whether it's studio or 1-bedroom apartment. There was leaf, there was cane trash, burnt ashes. And the question was asked why, and I don't think anybody could answer it more than when it was pointed out, look up. The vents that was in the roof to allow air into the building was causing so open that dirt and stuff would get in. Now, when asked a question, somebody said, but this is the same design we use in another place. Okay, yes, same design, but different environment. We had one nurse who started to use the property, and when she was using her kitchen, gray water came up in the kitchen sink. Gray water, ladies and gentlemen. When we checked, where the water came out of the building, right, into the manhole went nowhere. So all pipes led to the manhole, but the manhole had no outlet, so all water come back into other places. And this was a place constructed to be used. Because guess what? One, we're using contractors who are, they may have workers who are questionable in the things they're doing. 2, lack of supervision. 3, they appropriate, remember I said, applying appropriate technology to the situation. The design, a design for a piece of equipment may be applicable somewhere else. It may be great in England, but when it comes to Jamaica, where the traffic is more, it's something else. Kingston Public Hospital, for instance, I keep telling persons, sees over 2,000 persons a day. Over 2,000 persons a day. Do you understand then how many customers we're talking about? You understand then the demand for proper maintenance and proper engineering. Engineers are needed. Biomedical personnel are needed. Technical operatives are needed. If we are not having that done, we're gonna have a problem because we are not able to satisfy or to do the maintenance as we should. So just want to remember that we're talking about people's lives. Healthcare is about lives. It's not biscuit we're selling, it's not bread we're selling, it's not water, it's not drink. We're talking about positive outcomes on people's lives. So if we're talking risk management, we're talking person's life, we're talking highest potential for losses, we're talking lives, and we're talking liability. And what we're doing right now, we're matching the lowest set with the lowest pay package. For me, you put those two together, it spells disaster. My challenge to you and to the JIE and my fellow engineers is we need to get involved. We need to get involved. We need to let everybody understand that it's not maintenance, it's maintenance engineering and management. And that's where we need to lend our skill sets. I thank you. I think where time is concerned, I will take some questions.
Thank you very much, Engineer Boyd. You have given us a very clear picture of the situation that exists within our health sector. I just hope that by now you would have made some strive in improving what can best be described as a situation that needs a lot of help. I know we're running a little late with time, but I think we have a few questions. But before we ask our admin to provide us with those questions, I just want to ask you, you mentioned that you have to wait in some cases 1 month to have specialists coming here in Jamaica to service machinery. In light of COVID, where we would have to add another 2 weeks for a quarantine period, would you say we have invested or thinking of investing training money to train our specialists engineers at this time so as to be able to address the problem or fix any problem that we might have with the current set of equipment, biomedical equipment that exists here in Jamaica?
It's somewhat of a tough question to answer, but the truth be told, I know that the University of Technology and the University of West Indies have been trying to get their programs up and running and fully funded. The problem I think that there is right now is because one, you see, if I'm going to be trained in a discipline, persons want to know that they are going to be employed. Oftentimes, because of the posts that are existing in healthcare, it would affect the number of persons. So the universities I know are having that problems with throughput, with getting the amount of persons. And remember now, it's not just the numbers of persons, but getting persons with the right qualifications. Because there may be persons who can be trained at the technician level. And then for those that can go to the engineering level, they would have to have the required qualifications. All right. So I know there's a move and I know the government is trying, but as to whether or not it is sufficient, at this juncture in time, my personal opinion that there are a lot more needed to be done. And this is why the challenge to the engineers on the floor, those who are already engineers, because the discipline of clinical engineering requires that you are already an engineer. You get into healthcare, you learn more of your specific discipline also, but more that it's slanted towards healthcare. And therefore it makes it easier. If you're already an engineer, it is easier for you than somebody who's going to start just coming out of high school to go through the process. And that's why I appeal to, for engineers, not just to talk, but to participate, to volunteer, to help the health centers, to help the hospitals.
We want to.
I saw some questions in the question and answer.
Okay. Can we ask our administrators to ask the questions that have been asked by our participants?
No problem. Thank you, Mr. Ricketts. Our first question comes from Albert Gillings. He first says that it was very insightful, Mr. Godfrey. And his question is, what should we do at the planning stage? That is from the conceptualization of the asset or project?
Thank you very much, Albert. That's a very good question. As it is right now, a lot of the central buying is either done by the Ministry of Health through their engineering unit, or it is done from the regions through their directors of operation. The thing about it is that, because it's my opinion, so please, I stand to be corrected, that a lot of times we are not looking at the whole life cycle. So life cycle costing is not being utilized to its fullest. So we're not looking on the capital cost. We're not looking on the operating cost. We're not looking at what happens at the end stages of the equipment or systems. And we're certainly not looking at its impact on the customers, the patients. So it is very important that as we're doing any project, even if it's a building, that the nurses, the doctors, all those stakeholders are brought into play so that they can lend their expertise. Somebody who's from public health, for instance, could look at the building to say, okay, if we're talking about sanitization, as we're talking now about COVID-19, what is necessary, the type of equipment. Certainly a faucet, a bathroom faucet, or kitchen faucet is not the same in a health service. You may want to have a foot press where no hands touch a faucet. You simply step on it and you have water coming out. So part of what is important in the planning stage is to bring all the stakeholders together. Oftentimes what I think we do is we think of the capital costs, but it is too expensive. So we throw it through the door and we're not realizing the impact that it's going to have later on. I hope I was able to answer you.
Albert Gillings actually had a follow-up question as well. Right, he was asking if you do you develop an operations manual? Or is there an operations manual produced at the end of the implementation?
In most cases, it is the manuals that are that I know for the equipment is the manuals that have come from the manufacturers that are utilized in most cases. What really should happen, for instance, and there's another industry that I was a part of where commissioning becomes very critical. So before a piece of equipment is handed over to the user, it gets commissioned, and part of that commissioning processing, the process has to do with the manuals from the manufacturer, as well as you have asked, an operational procedure done so that it fits. So it links how we're going to operate it, how the operators are going to use the equipment, as well as how the maintenance and the engineering departments are going to interrelate and how they're going to respond. They're going to respond to what is there. So I can't say that it happens in all cases. I know in a lot of cases, though, what is used is the guide from the manufacturers.
All right, so we have another question from an anonymous attendee. They first thanked you for the presentation, Engineer Boyd. And from your experience, do we typically use a CMMS like SAP, SAP, Oracle, etc. in our facilities? Do we use predictive technology for these high-tech critical equipment? Are we more on the reactive side of the spectrum currently?
I would say it's a mixture of both. There are some places that does use a CMS. The problem with it is that it's not uniform. It's not uniform. In fact, there was a CMS that was employed by the Ministry of Health before. And the only place I've ever gone to see that use has been in the US Army, actually. And it was very, very difficult. But different regions and different places have employed different techniques. They have been using different CMS systems, as well as some just simply use, for instance, Excel database or some other database program to try to manage. But the correct thing would be to have a CMS so that, for instance, if I need a part and have a common machine all the way in the West, I should be able to see it. One of the things about the CMMS is the ability to have a drill down. So if I'm looking, for instance, on an X-ray machine, I should be able to drill all the way down to all the parts making up that X-ray machine and be able to know what spare parts I have in stock, what is the modalities in relation to maintain it and everything else.
Thank you. Now, Dwight Mears, he asks, what is your take on privatizing certain aspects of the maintenance engineering, whereas those entities are properly trained and monitored?
I'm all for private enterprise, but if controlled properly and if having the right specialty. You see, one of the things we have to consider is that the day-to-day operations in the health services also bring some challenges. And sometimes those challenges have to be responded to immediately. And it has to also be understood. One of the problems I have found whilst I sojourn in healthcare is that oftentimes the internal persons will know some of the nuances. The external contractor comes in, but they unfortunately are not delving in that aspect. They come in and they will fix. They're not going to do the assessment. They're not speaking sometimes with the persons who are utilizing the machine or who have had the problem and understanding why the problem came about. But if they are properly trained, especially specialists, so for instance, a civil engineer who has been trained in designing and building healthcare facilities, surely, because I'm not seeing the Ministry of Health being able to employ all the types of engineers that are needed. So there is that avenue, and there, unfortunately, a lot of modification, a lot of construction, a lot of modeling, remodeling have been done by contractors who are, the truth be told, they're just contractors out there, general contractors, not specialists. So there is the opportunity to do it.
All right, so our next question. So our next question is from Grantley Christie. He said that Mr. Boyd suggested that engineers should volunteer their expertise to the health service. How can an electronic engineer volunteer his/her time to service or repair equipment at, say, KPH or Spanish Town Hospital or any other hospital?
I'm sure, Grantley, that you could go through the Ministry of Health first and foremost. I am sure that they would welcome. Another trust is, and I say so, join the JIE, as the JIE has been lending itself to healthcare and other places. There are also, for each hospital, there are also what they're called Friends of the Hospital. So you could join one of those organizations also. A major development, we did a major development at the Bustamante Hospital for Children. A lot of persons don't know that. But the expansion for cardiac surgery for kids was a project done by the Rotary Club of New Kingston. And let me say it again. It was a Rotary project. I happen to have been involved with the club at that juncture in time as its president. And it got the involvement of a lot of other engineers and a lot of other persons externally. And today, right, monies were received from Digicel Ireland through Digicel Jamaica. And today, the facility is up and running at the Bustamante. So I'm sure for those of us here who are hearing, or those who somebody, they can reach out. The regional authorities, put it in writing. Let them know that you are willing to serve. Because I said sometimes it's not about the pay, Even for those persons who are working in healthcare, they're not greatly paid. But guess what? You see the outcomes? Going to a Bustamante hospital for children and seeing a child who was ill better, running, laughing, it brings so much joy. So I would encourage everybody to participate and to volunteer.
All right, thank you. We have one final question from Martin. Now, he said that this was an excellent presentation. It was very informative. His question is how can we improve the sector of maintenance engineering, and how can we recruit more young engineers to the sector?
Well, Martin, in answering that question to you, one of the ways of it is through institutions such as the JIE, is to have more educational programs for engineers, especially our young engineers. One, it gives knowledge, but two, it also opens up for the engineers so that they are aware that there's this need. And this is why, as we did the presentation this morning, I tried my best to point out the wide scope of services that are utilized in the healthcare and the need for engineers, right? So the idea is collaboration with institutions such as the PERP board, such as the JIE, the universities. Caribbean Maritime is doing an excellent job. UTEC, the University of the West Indies, and other tertiary institutions in Jamaica, is to get them on board with the Ministry of Health, with the government, so that we can sensitize persons out there, let persons know, young ones know that there is a career in engineering, but even more so, that there is a career in maintenance. You're not just a grease man. You're not just a tradesman, but you are an engineer. Thanks for the questions.
All right, thank you very much, Mr. Godfrey. All right, because of time, we can't go through the rest of the questions, but we'll ask Mr. Godfrey to respond or type his answer, right, as we move on to the other presenter.
Thank you very much. Thank you very much, Engineer Godfrey, for a very informative presentation. You covered a lot, and we just hope that this information will be channeled to the health sector and for them to take the necessary action so as to improve the state of our health service here in Jamaica.